Chapter 11, Part 2 of The Origin of Species by Means of Natural Selection by Charles Darwin. This recording is in the public domain. On the succession of the same types within the same areas during the later tertiary periods. Mr. Clift, many years ago, showed that the fossil mammals from the Australian caves were closely allied to the living marsupials of that continent. In South America, a similar relationship is manifest even to an uneducated eye in the gigantic pieces of armor, like those of the armadillo, found in several parts of La Plata. And Professor Owen has shown in the most striking manner that most of the fossil mammals buried there in such numbers are related to South American types. This relationship is even more clearly seen in the wonderful collection of fossil bones made by M.M. Lund and Clausen in the caves of Brazil. I was so much impressed with these facts that I strongly insisted in 1839 and 1845 on this law of the succession of types, on, this wonderful relationship in the same continent between the dead and the living, Professor Owen has subsequently extended the same generalization to the mammals of the Old World. We see the same law in this author's restorations of the extinct and gigantic birds of New Zealand. We see it also in the birds of the caves of Brazil. Mr. Woodward has shown that the same law holds good with seashells, but from the wide distribution of most mollusks, it is not well displayed by them. Other cases could be added, as the relation between the extinct and living land shells of Madeira, and between the extinct and living brackish water shells of the Aralo-Caspian Sea. What does this remarkable law of the succession of the same types within the same areas mean? He would be a bold man who, after comparing the present climate of Australia and of parts of South America under the same latitude, would attempt to account, on the one hand, through dissimilar physical conditions, for the dissimilarity of the inhabitants of these two continents, and, on the other hand, through similarity of conditions, for the uniformity of the same types in each continent during the later tertiary period. Nor can it be pretended that it is an immutable law that marsupials should have been chiefly or solely produced in Australia, or that edentata and other American types should have been solely produced in South America. For we know that Europe, in ancient times, was peopled by numerous marsupials, and I have shown in the publications above alluded to that in America the law of distribution of terrestrial mammals was formerly different from what it now is. North America formerly partook strongly of the present character of the southern half of the continent, and the southern half was formerly more closely allied than it is at present to the northern half. In a similar manner, we know, from Falconer's and Cowley's discoveries, that northern India was formerly more closely related in its mammals to Africa than it is at the present time. Analogous facts could be given in relation to the distribution of marine animals. On the theory of descent with modification, the great law of the long-enduring, but not immutable, succession of the same types within the same areas is at once explained, for the inhabitants of each quarter of the world will obviously tend to leave in that quarter, during the next succeeding period of time, closely allied, though, in some degree, modified descendants. If the inhabitants of one continent formerly differed greatly from those of another continent, so will their modified descendants still differ in nearly the same manner. So will their modified descendants still differ in nearly the same manner and degree. But after very long intervals of time, and after great geographical changes, permitting much intermigration, the feebler will yield to the more dominant forms, and there will be nothing immutable in the distribution of organic beings. It may be asked, in ridicule, whether I suppose that the Megatherium and other allied huge monsters, which formerly lived in South America, have left behind them the sloth, armadillo, and anteater as their degenerate descendants. This cannot for an instance be admitted. These huge animals have become wholly extinct, and have left no progeny. But in the caves of Brazil there are many extinct species which are closely allied in size and in all other characters to the species still living in South America, and some of these fossils may have been the actual progenitors of the living species. It must not be forgotten that, on our theory, all the species of the same genus are the descendants of some one species, so that, if 6 genera, each having 8 species, be found in one geographical formation, and in a succeeding formation there be 6 other allied or representative genera, each with the same number of species, then we may conclude that generally only one species of each of the older genera has left modified descendants, which constitute the new genera containing the several species, the other 7 species of each old genus having died out and left no progeny. Or, and this will be a far commoner case, 2 or 3 species in 2 or 3 alone of the 6 older genera will be the parents of the new genera, the other species and the other old genera having become utterly extinct. In failing orders, with the genera and species decreasing in numbers, as is the case with the Edentata of South America, still fewer genera and species will leave modified blood descendants. Summary of the preceding and present chapters. I have attempted to show that the geological record is extremely imperfect, that only a small portion of the globe has been geologically explored with care, that only certain classes of organic beings have been largely preserved in a fossil state, that the number both of specimens and of species preserved in our museums is absolutely as nothing compared with the number of generations which must have passed away even during a single formation, that, owing to subsidence being almost necessary for the accumulation of deposits rich in fossil species of many kinds, and thick enough to outlast future degradation, great intervals of time must have elapsed between most of our successive formations, that there has probably been more extinction during the periods of subsidence, and more variation during the periods of elevation, and during the latter the record will have been least perfectly kept, that each single formation has not been continuously deposited, that the duration of each formation is probably short compared with the average duration of specific forms, that migration has played an important part in the first appearance of new forms in any one area and formation, that widely ranging species are those which have varied most frequently, and have oftenest given rise to new species, that varieties have at first been local, and, lastly, although each species must have passed through numerous transitional stages, it is probable that the periods during which each underwent modification, though many and long, as measured by years, have been short in comparison with the periods during which each remained in an unchanged condition. These causes, taken conjointly, will to a large extent explain why, though we do find many links, we do not find interminable varieties, connecting together all extinct and existing forms by the finest graduated steps. It should also be constantly borne in mind that any linking variety between 2 forms which might be found would be ranked, unless the whole chain could be perfectly restored, as a new and distinct species, for it is not pretended that we have any sure criterion by which species and varieties can be discriminated. He who rejects this view of the imperfection of the geological record will rightly reject the whole theory, for he may ask in vain where are the numberless transitional links which must formerly have connected the closely allied or representative species found in the successive stages of the same great formation. He may disbelieve in the immense intervals of time which must have elapsed between our consecutive formations, He may overlook how important a part migration has played when the formations of any one great region, as those of Europe, are considered. He may urge the apparent, but often falsely apparent, sudden coming in of whole groups of species. He may ask, where are the remains of those infinitely numerous organisms which must have existed long before the Cambrian system was deposited? We now know that at least one animal did then exist, but I can answer this last question only by supposing that where our oceans now extend, they have extended for an enormous period, and where our oscillating continents now stand, they have stood since the commencement of the Cambrian system. But that, long before that epoch, the world presented a widely different aspect, and that the older continents, formed of formations older than any known to us, exist now only as remnants in a metamorphosed condition, or lie still buried under the ocean. Passing from these difficulties, the other great leading facts in paleontology agree admirably with the theory of descent with modification through variation and natural selection. We can thus understand how it is that new species come in slowly and successively, how species of different classes do not necessarily change together, or at the same rate, or in the same degree, yet in the long run that all undergo modification to some extent. The extinction of old forms is the almost inevitable consequence of the production of new forms. We can understand why, when a species has once disappeared, it never reappears. Groups of species increase in numbers slowly, and endure for unequal periods of time, for the process of modification is necessarily slow, and depends on many complex contingencies. The dominant species belonging to large and dominant groups tend to leave many modified descendants which form new subgroups and groups. As these are formed, the species of the less vigorous groups, from their inferiority inherited from a common progenitor, tend to become extinct together, and leave no modified offspring on the face of the earth. But the utter extinction of a whole group of species has sometimes been a slow process, from the survival of a few descendants lingering in protected and isolated situations. When a group has once wholly disappeared, it does not reappear, for the link of generation has been broken. We can understand how it is that all the forms of life, ancient and recent, make together a few grand classes. We can understand from the continued tendency to divergence of character, why the more ancient a form is, the more it generally differs from those now living. Why ancient and extinct forms often tend to fill up gaps between existing forms, sometimes blending two groups previously classed as distinct into one, but more commonly bringing them only a little closer together. The more ancient a form is, the more often it stands in some degree intermediate between groups now distinct, for the more ancient a form is, the more nearly it will be related to, and consequently resemble, the common progenitor of groups since become widely divergent. Extinct forms are seldom directly intermediate between existing forms, but are intermediate only by a long and circuitous course through other extinct and different forms. We can clearly see why the organic remains of closely consecutive formations are closely allied, for they are closely linked together by generation. We can clearly see why the remains of an intermediate formation are intermediate in character. The inhabitants of the world, at each successive period in its history, have beaten their predecessors in the race for life, and are, in so far, higher in the scale, and their structure has generally become more specialized, and this may account for the common belief held by so many paleontologists that organization on the whole has progressed. Extinct and ancient mammals resemble, to a certain extent, the embryos of the more recent animals belonging to the same classes, And this wonderful fact receives a simple explanation according to our views. The succession of the same types of structure within the same areas during the later geological periods ceases to be mysterious and is intelligible on the principle of inheritance. If, then, the geological record be as imperfect as many believe, and it may at least be asserted that the record cannot be proved to be much more perfect, the main objections to the theory of natural selection are greatly diminished or disappear. On the other hand, all the chief laws of paleontology plainly proclaim, as it seems to me, that species have been produced by ordinary generation, old forms having been supplanted by new and improved forms of life, the products of variation and the survival of the fittest. End of Chapter 11, Part 2.